Hello dear students. This is our next lecture that we are going to discuss today on is analytic functions. As we already know about these, what are basically analytic functions. We need to check the differentiability, whether if it is differentiable in some domain, right? If you choose some particular point, so it should be its derivative should exist within the neighborhood and the point itself. So that means its derivative should exist. Then we can say that the function is analytic, and in addition to that, if you talk about that, this Cauchy-Riemann condition should also satisfy, right? So that is basically the partial derivatives of, if you take its variation with respect to x, that should be. So that's very clear to you. So if you are new to this channel, so just visit my these previous these lectures. So it will be clear there what are basically Cauchy-Riemann condition, right? Basically, we are our mainly focus is on these problems about these the different topics that we touch in this mathematical physics. So this time we are basically discussing these complex functions, analytic functions, right? Now, our today's this question is that we need to show that this nabla of u should be equal to nabla of v. It holds for an analytic function. So first analyticity is that's clear. So that means so it should be differentiable, right? So first let me write that if we consider some analytic function. So we consider some analytic function that's f of z. Okay. So this is an analytic function because our u is a function of that x and y, right? Or you can rewrite this as so this is equal to x. Okay. Now we need to check that. So we need to check that nabla u should be equal to nabla of v, right? Or you can check if you calculate at some particular value, right? So you can also check this condition, right? So first let's write now. If you take this partial derivative first, so what's nabla of u here? So nabla of u you can write. So that's partial u by partial x. Okay. Or if you take this nabla u square, what's nabla u square? So that should be equal to that's equal to it's very clear. That's nabla u, so that's equal to this. Okay. Now if you use CR condition, so why I'm using this CR condition? So because our function is analytic, so for analytic function this Cauchy-Riemann condition should satisfy, right? So that means this partial u by partial x should be equal to. So these are our CR conditions. Okay. So that means partial u by partial x should be equal to partial u by partial y. And similarly, if you take it as variation of the complex part of that analytic function with respect to the x, it should be minus time, right? So this is very clear. I repeated it many times. So this is all that Cauchy-Riemann condition. Okay. Now, so we can use Cauchy-Riemann condition here because partial u by partial x you can write as. So you can rewrite this as because this is partial u by partial x. So partial u by partial x के बदले I can write that partial v by partial y. And similarly, partial u by partial y के बदले में लिख सकता हूँ minus partial v by partial x because this is partial u by partial y. So this will be the minus term because we have minus on our right hand side. So partial u by partial v will be minus term in this, right? So I can rewrite this term as so nabla of u square will be equal to. So that will be equal to partial v by partial y. So partial it is partial by partial x. Huh? So it is sorry. So just use here. So this will be partial v by partial x. Okay. Or this will be equal to can write this as, sorry, so we can write this as, this will be equal to, because so this is basically that you are now taking partial v by partial y plus ka whole square plus partial v by partial x ka whole square, right? But this is our that nabla of v, right? Because we can write what's nabla of v. So nabla of v, you can write this as, so that is partial v by partial x. So this is very clear because so this will be nabla v. Or you can rewrite this as, so you can write this as that. Okay, right. So this is what we need here because our that that topic was, it was basically we need to show that nabla of u should be equal to nabla of v, and it holds only for an analytic function, right? Because we choose that we can write that nabla u because our this is our this Laplacian, this is our that nabla, it is basically in the complex plane, xy plane. So that is why I am only taking the two dimensions, so partially by partial x and y coordinate, right? Because we have this complex plane, so we are working in a plane, not in a three dimension, right? So that's why it has that partial by partial x plus this, right? And then we have proved that. So where is that? Okay, so we have proved that this nabla u square should be equal to this, right? So this is what we have calculated. Now further, if our function, if we consider some function, right? Now if I consider now, uh, uh, if I consider now, so I will take one more example. If I take now, if fz will be equal to z square, okay, and we need to show that that nabla of u should be equal to nabla of u, right? So we can, so this is very easy, right? So you can write now, because we can write, because if this is analytic function, right? So we can write that f of z will be equal to x plus iota y. So that's equal to x. Okay. This will be equal to, okay. So this is our f of z. तो ये हमारा f of z है, because I am writing that f of z square because if this is our complex number, so you can write that it's x plus iota y and this is equal to this. So that means if you compare this with this, because our f of z is, that is plus iota of u of x. Okay, so that means u of x y will be, that will be equal to that's x square minus y square. Okay, so this is u and v. So what we have to prove? So we need to prove that nabla of u should be equal to nabla of v, absolute value, mod of this. Okay. So first you write what's nabla of u here. What's nabla u here? Because nabla u of u is, that's partially by partial x. Right? Now you take its variation, this variation with respect to x, so that's 2x I cap minus 2y gt. Okay. So this is our equation first, right? Because first we calculate that nabla of u, right? Now if you take its absolute value, So take its absolute value because we need to calculate that absolute value of nabla u should be equal to this thing, right? So we can write then what is absolute value of this. तो जस्ट चेक. तो अगर हम देखेंगे यहाँ पे जो हमारा नबला u दैट इज 2x I cap minus 2y j cap, right? When you take its absolute value, that is square root of 2x का whole square, it should be then plus 2y का whole square, right? So that means this will be equal to, right? So that's equal to, or if you take it as square now, right? And similarly, if you calculate now nabla of v, because what's our nabla of v? So we need to calculate v is our minus 2xy, yeah? So that means our v of xy xy, huh? Or you can write what's our nabla of v? Sorry, so we need to write because this is v here, huh? Okay, so this will be equal to, because when you take this variation with respect to x, so this will be 2y, that is minus 2y I cap, and now take its variation with respect to y, so that's minus 2x. Okay, so this is 2y because when you take its differentiation with respect to partial differentiation with respect to x, तो ये बन जाएगा minus 2y, so that's our first term. And ऐसे ही अगर हम इसकी डिफरेंशिएशन करेंगे with respect to y, तो ये बन जाएगा minus 2 of x j cap, right? And if you calculate now what's this mod of v here, so that will be equal to square root of, okay, so that is equal to square root of, or you can write this as, so that means our nabla u square is this thing and nabla u square is this thing. So if you compare this equation with this equation, right? So if you compare this equation with this equation, so you can write that so what does that mean? So यहाँ पे so we conclude one thing here that अगर हमारे पास कोई function होगा, if we consider some complex function which is analytic, so it can be or it cannot be analytic, right? But this is mandatory, this is important. ये important condition है कि जो हमारी function होनी चाहिए that should be analytic, right? So if it is analytic function, so we can say that then nabla u should be equal to nabla. So we can consider any function अगर हम कोई भी function लेंगे, right? So that means we can say that जो इसकी variation हम लेते हैं, if you take nabla of u, so if nabla u of u is clear, so you can calculate then v from there also. So there are many ways how you can calculate the real part from the complex part or complex part from the real part. So as we have discussed, so with the help of these Melville's method, so we can talk about that. अगर हमारे पास एक part पता होगा, if we know the real part of our complex this analytic function, so we can calculate it as this. I can construct the whole complex this analytic function, or I can calculate the complex function, complex part of that analytic function, right? So there are many ways. So hopefully we will discuss in our coming lectures. So this was all about the what should be the minimum criteria for if we consider some function which is analytic. So the criteria is that this should be equal to this thing, right? और यहाँ पे मैंने आपको एक एग्जांपल भी दिखाई that अगर हमारे पास एक फंक्शन होगा that f of z is equal to this thing, right? So we can prove that nabla u is equal to nabla v. So that means when nebula u equal to nebula v, so our function will be analytic in that case. So that means ये हमारी analytic function है. तो ये दूसरा way है. This is the other way how you can check whether the given function is analytic or not, right? So this was another problem that basically I took. So there, now one more problem is on, if you talk about now, one more problem is that we need to show that this integral, because this is in our complex planes, right? So this integral that z star z, it depends upon the path by evaluating the integration for two paths. Because if we evaluate this integral, so because we need to evaluate that, so limit is going from 0 to 1 right? So ये हमें evaluate करना है, and the integration are, you are taking two different paths. You can choose two different paths to calculate, to go from this point to that point, right? Or you can go through path number first, or this is our path number second. So that ऐसे जाना है या आप ऐसे भी जा सकते हो, right? So in both the cases you can calculate that integral, right? And so there is the condition. So first let us talk about this. If we have this, so you need to, so this integral depends upon the path by evaluating the integral. Integration for the two paths as shown in the figure, right? So we can choose two different paths for this, right? To calculate this integral. Now, so recall that this f of z. So this is basically z star. It is not an analytic function of z. So that means हम कह रहे हैं कि जो हमारा z star है, it is not analytic function of z, right? And the Cauchy integral theorem does not apply, because Cauchy integral theorem cannot be applied here, because Cauchy integral theorem stated that if we have a closed path and function is analytic, right? So integral theorem जो Cauchy integral theorem है, तो Cauchy integral theorem tells us Cauchy integral theorem tells us that अगर हमारे पास एक function होगा, if I have a function and which is analytic within a given region of space within some domain D, so we can say that the total integral, the closed integral of that analytic function will be 0. So that means we have this kind of function. That means that f of z, that should be equal to 0 for a closed. Okay. So this is basically for, so as we have discussed this in our regular classes, what is basically Cauchy integral theorem. So this is one of the problems that I took for this. So one of the problem from this Cauchy integral theorem, right? So we need to evaluate this integral, and the condition is like this. So we have this f of z star, it is not analytic function of z, and the Cauchy integral theorem does not apply, right? So we need to check that. So let us suppose now we have this. This is basically our that complex plane, and these are our points 1, right? And we need to integrate. So we can choose that path number first. So this is our path number first. So this is path first, and this is our path second. So we can go either way, right? So we can go through this way and that way. But what basically, if you remember that Cauchy, this integral theorem, second state is that if we can calculate that integral from this point to that point, and this integral is independent of the paths. अगर हम यहाँ से जाएंगे, if we go towards our left, if we go towards path first, or if we go towards path second, in both the cases, this total integral will be same. तो यहाँ पे हमें प्रूव क्या करना है? What we have to prove here? So we need to prove that this the integral that we take from this towards path first, so that will be different what we get when we solve this integral when we go through path second. तो दोनों साइड में path जो integral हमारा आएगा, that should be different, because I am saying that our absurd is equal to z star, that's not analytic function of z. तो Cauchy integral theorem हम usually use करते हैं किन के लिए, where our function will be analytic, right? So let us solve this problem, right? So that means we can write that what's our absurd here. So that's our z star, and this will be equal to some x minus iota. Okay. So that means our z will be, that's our x plus iota. So if we solve this integral, right? So because we need to solve for this z star here, right? And what about this dz here? So what is dz? So that will be dx. Right? So if we solve this integral for 0, 0 to 1, 1, that is z star. right? Why I'm taking this? Because I'm saying that our z star is not analytic function, right? So that means we should what we should expect from this problem, that the integral that we calculate for two different paths are different, right? So we can calculate that. So let's write this as, so this is simply what I did here. I basically write z star. So z star is our x minus iota y, and our dz is, that is dx plus iota dy, right? Because this is our real and imaginary, so this is our complex plane, so this is clear. Or if you want to separate, so let us separate these real and imaginary parts separate, right? So I can rewrite this as, or you can write this as, okay, let's write first separately. Okay, so you can use it like this. Okay. So let us, we have now two integrals here, right? So let us solve this through path first. So because we have two paths, तो हम ऐसे भी जा सकते हैं, or we can go through path second, right? So let us choose path first. So in path first, you can write this as, so let us choose path first here. Okay, so this is our path first, this is our path first, or this is our path second, right? So let us choose path first now. So in path first, we need to integrate x keeping y equal to 0. Because when you choose path first, what I'm saying now, so we need to integrate x, right? So x को integrate करना है and keeping y equal to 0. Why? Because हमें कौन सा देखना है, यहाँ से यहाँ तक हमें जाना है, right? So we need to go from the origin to this point. So in यहाँ पे मुझे क्या करना है? So I can have only x variation. Y variation will be 0, right? So that's why what I wrote here, you need to integrate this, integrate x and put y equal to 0, right? So this is our path first up to this point, right? And then for this one, तो जो ऊपर वाला है, when we go upwards to the point 1 1, तो यहाँ पे हमें क्या है, you need to put x 0, right? X constant, x का value क्या है, that is 1 1, right? Because this is basically this point, it is the projection of, so the projection of this point on the x-axis gives us the value of x, and projection of this point on the y-axis, the imaginary axis, gives us the value of y, right? So that means जो हमारा ये point है, that's 1 here, right? तो ये भी point हमारा 1 है, तो इसीलिए मैंने first part जो हमें integrate करना है इसको x, because I am going from this point to this point, इस point से इस point तक हमें जाना है, तो उस time हमें we need to integrate over x, calculate the total area, right? But I am putting that y should be equal to 0 because y remains 0. So over this line, over this x-axis, real axis, our y will be 0. So this is for first part, right? And for second one, you need to integrate now y because y is changing now. Y is going from 0 to this. So y you need to integrate and keeping x as 1. तो यहाँ पे जो x का वैल्यू होगा वो 1 होगा, right? So that means you can write that तो क्या मैंने लिखा, तो पहले हमें इंटीग्रेट x करना है, कीपिंग y इक्वल टू 0, तो y यहाँ पे 0 रहेगा। उसके बाद हमें देन इंटीग्रेट और y, क्योंकि ये वैरी हो रहा है, एंड पुटिंग x इक्वल टू 1, बिकॉज यहाँ पे ऑलरेडी x का वैल्यू 1 है, राइट। सो वी कैन राइट दैट, सो दिस इंटीग्रल विल बी इक्वल टू that is to write it here, because I can write this as plus and putting that x equal to 1. Okay, so this is what we have. तो पहले हम, ये हमारा इंटीग्रल यहाँ से लेके यहाँ तक है, इस वाली लाइन तक, जो हमारी ये लाइन सेगमेंट है, and plus iota, because now we have imaginary axis, so this is our iota here. Okay, iota, and then you need to integrate over y, but put x equal to 1, right? So let's calculate this. तो अगर हम इसको कैलकुलेट करेंगे, so what will our first term? तो यहाँ पे मुझे क्या लेना है, x इक्वल टू 1, y इक्वल टू 0, तो जब y 0 बन जाएगा, तो आई कैन हैव ओनली इंटीग्रल फ्रॉम 0 to 1 x dx, right, and iota of 0 to 1 okay, तो ये बन जाएगा x dx प्लस okay, that's clear. So this x dx, because y equal to 0, so ये जो बन जाएगा 0 to 1 x dx, और यहाँ पे क्या करना है हमें, we need to put that x equal to 1, so this will be 1 minus iota y dy, and iota is outside already, so this is from this equation what we have done. So this comes out to be, this is x square by 2, right? So this will be equal to, so what's inside then? Okay, no, so what we did here, because इसकी डिफरेंशिएशन आएगी, इसकी इंटीग्रेशन आएगी y, so you need to put it y 1, so this will be y minus iota y square by 2, right? So this is what I did here. Okay, so that's clear. So this will be here y here when you integrate this, because यहाँ पे already 1 था, so if you check that, यहाँ पे आएगी ये 1, इसकी इंटीग्रेशन आएगी y minus iota y square by 2, then you put this in. So this is what I did here, y minus this thing, huh? This will be equal to that 1 by 2 plus iota into 1 minus 0 plus 1. So this is basically along first path, जो हमारी फर्स्ट पाथ थी, तो उसमें हमारा जो वैल्यू आएगी इंटीग्रल का, सो दैट इज आयोटा प्लस पाथ, एंड सिमिलरली इफ यू चूज सेकंड पाथ, सो पाथ सेकंड, जो हमारा पार्ट 2 है, तो जस्ट चेक हियर, तो व्हाट्स ऑल पार्ट टू, तो पार्ट टू में क्या बन जाएगा, तो पार्ट टू में हमें क्या करना है, वी नीड टू इंटीग्रेट, पहले में इंटीग्रेट करना है along y, right, and putting x equal to 0. So integrate over that y, putting x equal to 0 because यहाँ पे 0, there will be no change in x along this path, right, and then integrate over x, putting y equal to 1 because यहाँ पे y का वैल्यू क्या होगा, यहाँ पे y का वैल्यू होगा 1, तो यहाँ पे y का वैल्यू 1 होगा, राइट, तो दैट मीन्स यहाँ पे इसका रिवर्स आ जाएगा, यहाँ पे पहले हम x वैरी कर रहे थे, y 0 ले रहे थे, देन y वैरी कर रहे थे, x 1 ले रहे थे, नाउ इट विल बी रिवर्स ऑफ दैट, राइट, यहाँ पे हमें पहले वैरी y करना है, x 0 लेना, बिकॉज ऑन दिस इमेजिनरी एक्सिस y एक्सिस और x इक्वल टू 0, एंड देन यहाँ से फिर हमें इंटीग्रेट करना है x, नाउ x इज वैरिंग व्हेन यू गो दिस वे from this point to that point. So you need to integrate over the x and putting y equal to 1 because y is already 1 here, right? So you can write this as, so in second case, so you need to again that, you write that integrate over y and put x equal to 0, then integrate over x and y, right? So this is what, तो ये इसका रिवर्स आ जाएगा बिकॉज फर्स्ट वी आर वेरिंग एक्स देन वाई, तो यहाँ से जब वी गो थ्रू पाथ सेकंड वी आर वेरिंग फर्स्ट वाई देन वेरिंग एक्स, राइट, सो दिस इज व्हाट आई रोट इन वर्ड्स, राइट, so you can write this as 0 0 putting that x equal to 0, sorry, okay, so this is, okay, so you can write this here also, right, because this is y equal to 1, right, right, so you can, okay, so I need to say something here because जब हम वेरी कर रहे हैं, so you just check that, जब हम वेरी यहाँ पे कर रहे हैं, फर्स्ट वाला जो इंटीग्रल होगा वो हमारा ये वाला जो इंटीग्रल है सेकंड पार्ट इसका, तो दैट मीन्स इसके लिए हमें इंटीग्रेट करना है ओवर y बट पुटिंग x इक्वल टू 1, राइट, एंड सिमिलरली जो सेकंड वाला होगा ये हमारा रियल पार्ट होगा इसका, राइट, तो दिस इज, तो इसलिए मैं कह रहा हूँ यहाँ पे जो हमारा x में हटा हुआ होगा इट इज फ्रॉम 0 to 1 बट पुटिंग दैट y इक्वल टू 1, this is dx plus iota integral from 0 to 1 सो जस्ट चेक, तो ये हमारा पहला वाला पार्ट है, तो ये हमारा ये वाला पार्ट है, तो जैसे हम दे रहे हैं कि दिस और पार्ट, तो ये वाला जो हमारा है, सो दिस और दिस थी, क्योंकि पहले वेरीफाई कर रहे हैं, राइट, बिकॉज दिस और इमेजिनरी पार्ट, राइट, सो रिमेंबर दैट, तो इसलिए मैं ये वाला ले रहा हूँ बिकॉज आई वेरिंग आई गोइंग थ्रू इमेजिनरी एक्सिस, तो उसके लिए हमें ये पार्ट लेना है, इसको हमें वेरी करना है, तो वी नीड टू इंटीग्रेट ओवर वाई एंड पुटिंग एक्स इक्वल टू 0, सो ये पार्ट हमारा ये है, एंड उसके बाद ये वाला पार्ट है, सो दैट इज when you integrate over x, so you are integrating over x and putting that y equal to 1, right, so that's, so a little bit, so you need to be cautious, so what should be the limit and which value of this integral you have to integrate with respect to what, so this you need to remember that, yeah? So you can rewrite this as, so this, so this will be equal to that 0 to 1 So what should be the first integral? Because y हमें यहाँ पे 1 लेना है. So this will be equal to okay. This will be equal to okay, sorry, x delta x delta x. Because you need to integrate this. Okay, so this will be x square by 2 and this will be iota x. Okay, that's it. And plus, because this will be plus here because iota square, that's minus, and this will be minus plus. And this will be y square by. Okay, so this will be equal to, you write that 1 by 2 minus iota plus 1. That's equal to 1 minus. तो जस्ट चेक द रिजल्ट. जो हमारा सेकंड इंटीग्रल यहाँ पे आया, तो जो हमारा सेकंड इंटीग्रल यहाँ पे, सो दैट इज व्हेन वी गो थ्रू पाथ सेकंड, राइट. तो हमारा जो इंटीग्रल आया, so that's 1 minus iota, right? And you just check जो हमारा फर्स्ट पाथ आया था, when we calculate that is 1 plus iota, iota plus pi. So what we conclude that we can say that जो इंटीग्रल हमारा पाथ फर्स्ट आया, तो इंटीग्रल ऑफ दिस z star dz through path first, that is 1 plus iota, and integral through path second z star dz is 1 minus iota, right? तो दोनों में हमारा डिफरेंट वैल्यू आया, बट व्हाट बेसिकली कॉची इंटीग्रल थ्योरम टेल्स अस, तो दैट मींस वो कह रहा है कि इफ वी हैव दिस कॉम्प्लेक्स प्लेन दैट इज रियल एंड इमेजिनरी पार्ट and we want to go from point A to point B in that complex plane. So we can go this way, that way. So you can choose different paths, right? So, but the total integral here, the total integral will be same. So it will be independent of the path. So that means this is along C1, this is C2. So we can say that the integral was C1 f of z dz. So that means जो इंटीग्रल यहाँ पे आएगा टोटल, either you go through path first or you go through path second, so integral will be same, so it will be independent of the path. But what we have seen here, that the integral through path first is that's 1 plus iota, and the integral when you calculate over the path second we have this 1 minus iota. So that means the integral in two different parts are different, right? So when it is different, so that means this function will not be analytic. तो हमने ऑलरेडी पहले ही कहा था कि जो हमारी फंक्शन है दैट z star is not analytic function of z, right? So then we can say that, so with the help of this Cauchy integral theorem we have proved that the function is not an analytic function, because this is only for when this function f of z, so this is only possible when the function f of z will be analytic within this domain, right? So this was all about this. This was one of the problem on this Cauchy integral theorem, and similarly we will discuss some more problems on this Cauchy integral. So there are 3-4 theorems. So at least I'll just check. So the relevant problem that are most probably asked in your competitive exams. So I will touch those problems. Right? Thank you very much.